All right, folks. One final trig video here to help us out a little bit and finish off trig for the year. And you're not going to have a homework assignment about this, but I do want you to kind of just see a couple polar graphs just so you have an idea what they look like. If we wanted to really dive into this, we'd be talking about their symmetry and some other things like that, but we're not going to really deal with it too much. We're just going to graph a couple so you can see it, and we'll go from that. So anyways, first up, just a quick little review. How do you graph polar points? So do me a huge favor. Why don't you guys go ahead and graph these polar points? And apparently this one got a little cut off there. This is the point pi over 4. So go ahead and take a second and graph each one and label them, and then we'll see how you did. All right. 5, 2 pi over 3. So here's 2 pi over 3. I'm going out 5. So 1, 2, 3, 4, 5. So here's that one. 5, 2 pi over 3. That's A. All right, now let's try B here. We have pi over 4. That's this direction right here. But it says that I'm going in a negative direction. So I'm going back 3. I'm going back 1, back 2, back 3. Oh, I almost hit the line there, didn't I? There we go. All right, and that will be B. All right, last one. 4 negative pi over 6. So I'm going in a negative direction. I'll be at 11. Negative pi over 6 is 11 pi over 6. So I'm going out 4. And there's C. So what we're going to do is we're going to graph some polar coordinate graphs just so we can take a look at it. So we'll try to figure out then, using our conversions, which one we're actually looking at here. So just for the fun of it, I'm going to add that back in here. Let's see here, x squared plus y squared equals r squared. And let's see, we probably need to also have x equals r cosine theta. So after I get done graphing this one, we'll see how it relates to rectangular coordinates. And then I'm going to have you guys do one. You won't have to relate it yourselves. I just want you to kind of have fun with it a little bit and see a graph a little bit. And then we'll go ahead and try it. All right. So we're going to start off on each of these. We're just going to take our theta and we're going to plug it in. So this one right here would be 4 cosine of 0. This one would be 4 cosine of pi over 6. So we're just going to plug in all our values and then figure out what this graph looks like. So do me a favor, go ahead and fill out the table real quick. So pause the video, fill out the table, and then I'll come back. All right, so you guys are back with me here. Let's see if I can actually go ahead and do this here. 4, 2 root 3, by the way, when I do graph this, I'm going to need to know what that decimal is. So that'll be 3.464. We have 2 root 2, and that's going to be 2.828. Then we have 2, 0, negative 2, negative 2 root 2, negative 2 root 3. So we're just plugging our numbers in so we can kind of see what they look like. So we're just going through, we plug them all in here. Negative 2 root 2. What do we have there? Negative 2 and 0. I went ahead and did these earlier so that way I could kind of go through this a little bit quicker for y'all. Like I said, I'm not going to give you guys an assignment over this. I just want you to kind of see what some of these polar graphs would look like when you put it all together. So here we go. And we're going to go through and graph this graph here. So when it's 0, at 0, my value is 4. So 1, 2, 3, 4. That was a little off. Let's see if I can be a little better than that here. There we go. Then at pi over 6, I'm at 3.464. That's about 3.5, so I'd be right about there somewhere. And then at pi over 4, it's 2.828, so that's a little bit below. And then at pi over 3, it's at 2. And then I'm at 0. So let's try to take a look at what this graph looks like to begin with. There we go. So it looks kind of something kind of like that. It's like a little semicircle here. So at 2 pi over 3, I'm at -2. So 2 pi over 3, I went back 2. And then at 3 pi over 4, I was at -2 root 2, and that's -2.828 again. So I'd be right about there. And then I had -3.464, so I'd be right about here. And at pi, I'm at -4, which would be here. Turns out I'm back to the exact same spot I started at. That happens sometimes. That doesn't mean that I'm just going to stay there. And then let's see what happens here. 7 pi over 6, I'm at -2 root 3. Well, it does look like I'm going to be going back over the same points. 5 pi over 4, that's -2 root 2. 4 pi over 3, that's -2, and 0. So I am going out and doing the exact same points. And when you graph this, it kind of looks like it is a circle. So the question I got is it really a circle? Well, let's take a look at our graph and see if we can't figure this out here. Is it actually a circle? Because that's kind of what it looks like. Is this the polar form of a circle? Well, I don't have anything to deal with cosine theta, but I do have something that deals with r cosine theta. So what if I multiply both sides by r? And again, you wouldn't have to do this kind of thing, but it looks like I graphed a circle. I'm curious, is that actually a circle? Whoopsies. 4 times r cosine theta. So r squared, that's the same thing as x squared plus y squared. Equals 4 r cosine theta is going to be x, so 4 times x. So if I set them equal to 0, I get x squared minus 4x plus y squared equals 0. And it kind of looks like I'm dealing with a little bit of a conic section. So I'm going to go ahead and see if I can't take a look at this here. Equals 0 plus. So we take that middle number, -4 divided by 2 is going to be -2, and I squared, I get 4. So I'm doing my conic section stuff here, completing the square a little bit. And I end up getting x minus 2 squared plus y squared equals 4. It does look like that I have a circle that has a center at 2, 0, and a radius of 2. If I think of this in terms of an xy axis, and again, you wouldn't have to ever do this part, but looks like I have a circle at 2, and does it have a radius of 2? Well, it kind of looks like it. As a matter of fact, it does. So that would be about what I would be looking at as far as this right here would have been the conic form, I'm sorry, the polar form of a circle. So this is actually indeed a circle. So we'll go ahead and take a second here. Here's your next equation down here. Why don't you guys do me a favor? Go ahead and pause the video and see if you can evaluate the table below it for that equation. Go for it. All right, let me see if I can't go down there here a little bit. I'm gonna go ahead and again, I'm plugging in all my numbers here. So when I'm plugging this in here, this is going to be 5 times sine of, so I'm plugging all these thetas in, so 2 times 0. And so that's kind of what you were looking at when you're plugging these in. You're taking all these thetas and you're plugging them in. And again, there's a way to graph with symmetry and other things like that. But we're just not really going to worry too much about that here. So this would be 5 root 3 over 2. So go ahead and check you guys' values if you went ahead and evaluated to see what you came up with. Pi over 4 would have been 5. 5 root 3 over 2. 0. Negative 5 root 3 over 2. Negative 5. Negative 5 root 3 over 2. And 0. And we keep going here. 5 root 3 over 2. And then we have 5. 5 root 3 over 2. And 0. And let's see, I got negative 5 root 3 over 2. Negative 5. Negative 5 root 3 over 2. And 0. So let's see if we can't make a little graph of what this looks like. Here we go. When I'm at 0, this is going to actually be 0. So I'm going to go and put a dot there. At pi over 6, I'm going out to 4.33. So 1, 2, 3, 4.33. So about 4 1/3. It's actually not quite 4 1/3. And then I'm at 5 at pi over 4. And then I'm at 4.33 again. And then I come back to 0. So when I graph it, it looks kind of like, oopsie, I don't want to use that. Let's try that. Kind of curve it a little bit. Well, since I'm back at 0, I'm going to go ahead and change up my color so I can kind of see what the next one looks like. So at 2 pi over 3, I went negative 4.33. So that's going to go down. And so let's see here. First up, this was the red part. Red. And now I'm going to go ahead and do green. I got a feeling I'm going to be back at 0 again, so I'll go green there, just so we can see it. So at 2 pi over 3, I'm going back to negative 4.33. So I'll be right back there. And then I'm at negative 5. And then negative 4.33, and pi brings me back to 0. So now the graph from here, so I have a negative radius, so I shot the pole, and I'm going backwards on this part. All right, I'll try purple from here for the next little bit. So at 7 pi over 6, I'm at 5 root 3 over 2, so that's going to put me back at 4.33 again. So I'm curving it out. And then at 5 pi over 4, it's 0. And then we have 4 pi over 3 is 4.33. So when I graph this one, it looks like this. And then let's see, I'll go ahead and end with blue here on this last little bit. And at 5 pi over 3, I'm going backwards again to negative 4.33. So I went backwards again. And then I'm at negative 5 at 7 pi over 4. At 11 pi over 6, I'm at negative 4.33 again. So I'm going backwards again. And the graph looks something kind of like this. And we're back to the beginning again. And what does it kind of look like? You said a flower, you'd be right. This is called a 4-petal rose. A lot of these polar graphs make really cool shapes. They'll make roses, I think it's called Lynchcombs, they'll make things called, they'll make hearts, they'll make circles like we saw before in the one before. They give all kinds of cool little shapes. They're kind of fun to play with. So if you wanted to, you could actually put your calculator's mode into polar form, and you can go ahead and play around with this and just see some of the different graphs they make, because they're kind of fun. Anyways, folks, that'll kind of take care of polar graphs and takes care of trigonometry. So we'll come back in class tomorrow or next week, and we'll start going ahead and reviewing for our final unit test in trig. All right.